Good afternoon, everyone. It is my pleasure to welcome you to this Interreg Europe Policy Learning Platform workshop on meeting the Biowaste Challenge. My name is Astrid Severin, and I'm a thematic expert for environment and resource efficiency at the Interreg Europe Policy Learning Platform. I would also like to welcome my very knowledgeable and trusty colleagues, Elena Ferrario, thematic manager of the Interreg Europe Policy Learning Platform, Katarina Krell, thematic expert for low carbon economy, Magda Michalikova, also a thematic expert for environment and resource efficiency, and my colleagues Eugénie Suplisson and Soroush Brandenburg from our communications team. Hello to all of you. So before we are starting and people are still joining us, just some housekeeping rules. We are, of course, recording this webinar. I think you have seen that. The recordings and all the presentations will be available afterwards as well, together with a hopefully informative article. We would kindly ask you to all mute yourself when you're not speaking, and you can leave your cameras on. We want to have a workshop, and it's always nice to see everybody when we are on there together, but at least online, it's always a nice touch. If you have questions, please do not hesitate, write them in the chat and ask us. Also post useful information and links is always very welcome. And of course, you can always raise your hand as well for any questions or contributions. Finally, we would kindly ask you to fill in a feedback survey. We will post that also in the chat, and we will remind you again at the end of our workshop so that we can hear from you what you thought about the event and also what you would like to do in the future. We have prepared a little poll to also get to know you a little bit better. And I would ask Eugénie to launch our poll to this end. So our first question is asking you, what is your background? So are you from a regional local authority, waste management organization, or a company or an NGO? Or another organization that is interested in the Biowaste Challenge. So please vote now. Okay. Oh, good. We have a lot of regional local authorities with us, also some companies and waste management organizations, and a lot of other organizations. Well, it would have been interesting to know what that is. So maybe you can mention that in the chat if we don't know. So the second poll, we would like to ask you, why are you here with us today? And you have the possibility to do some multiple choices, of course. You might have several reasons, ranging from achieving a better recycling rate in your region or municipality, improving soil and water quality, implementing biogas plants, or enhancing composting schemes. And of course, you could also be here to learn more about the policy learning platform and the opportunities it offers, or find partners for future projects. So please vote also on this. And as I said, you have a multiple choice. Okay, so let's see. Wow, so we have a lot of interest in achieving better recycling rates of biowaste, so 71%. So you're in the right place, I would say. Of course, biogas, composting schemes, everything interesting, and learning about future partners in the policy learning platform, excellent. So I think we can offer you all of this. And we welcome you again to this workshop. We have a very interesting and packed agenda today, which can answer many of the questions that you're having. We're really pleased to have excellent keynote speakers, Jean-Benoît Bel from the Association of Cities and Regions for Sustainable Resource Management, also known as ACR+. So hello, Jean-Benoît. We have Mieke Decorte from the European Biogas Association. Hello to you as well. And then we will have 2 targeted parallel sessions where we, in the first session, will discuss everything related to biogas, moderated by my colleague Katarina. So we are happy to have Pekka Maijala from Finland with us, Linda Genander from Sweden, and also Christos Karakanias from Thessaloniki from Greece. Hello to you. In the other parallel session, we will be speaking about composting, and we have Frederica from the municipality of Casal Grande, which is speaking about home composting. Martin Wallach from the Slovak University of Agriculture. Hello to you. And we also have Dimitris Yiannopoulos, who is coming from Western Thessaly to us. We will then come together again in the plenary session where we can hear about the feedback from these 2 sessions so that everybody can benefit from all the discussions. And we also have a very interesting presentation from Marie Guiton. Hello to you, Marie, who is policy officer at the Interreg Europe Secretariat, which will tell us about the future opportunities that Interreg Europe and also the policy platform are offering. And you will also have the opportunity to vote on future subjects that you find interesting and you would like to discuss in the future with us and get more information and policy learning opportunities. And at the end, we have offered you an online expert help desk. So many people have registered for that help desk. We are all sitting here to welcome you. Should you not be able to use this opportunity, please let us know, because there is a waiting list already for this help desk. So please make sure that that you're using this opportunity and let other people also use it should you not be available. So before we are going to give the word to our keynote speakers, just some short messages. This is Interreg Europe, as you know it. It has 30 countries participating, 359 million euros were invested in policy learning. Many partners have been participating in projects around the 4 key areas of research and innovation, SME competitiveness, low carbon economy, and also environment and resource efficiency, which is the subject under which we're meeting here today. You can see here how this subject has been treated. We had 31 projects which were dealing specifically with resource management for areas such as water, waste, and environmental performance management. We also had, of course, projects specifically focusing on the circular economy. 11 projects have been working in this area. And the projects have been very busy and very successful. Impressive results have been achieved as of last year. We had more than 1,000 good practices that have been coming from the environment and resource efficiency projects. Already 191 policy changes had been implemented, and a lot of money, a lot of funds had been influenced through these projects. So as we are discussing today the Biowaste Challenge, we have also prepared what we call a policy brief, a document which you can find on the Interreg Europe portal, and also a link to it in the chat. Here we have a lot of examples from our different projects, what they have been doing in that area. But we also have contributions from the European Biogas Association, from ACR+. We also go into depth on the policy context and some EU financial support that is available. And of course, we also deliver some recommendations. I think you're all here because the European framework for biowaste is requiring a lot of changes, a lot of things that are coming up, and the regions and municipalities have to adapt for the separate collection of biowaste, for example, by the 31st of December 2023. So door-to-door collection, collection points, home composting are all very interesting concepts in this regard. And of course, everybody wants to support this recycling target of 65% of municipal waste. We have heard that that's the main interest that you're having for attending this workshop. And the biowaste treatment is going to play an important role in that through material recycling with the help of anaerobic digestion and composting. So a lot of policy solutions are being presented in this policy brief and also here today. So we are speaking about solutions that have been generated in the projects Interwaste, OptiVamag, LCA for Regions, SESME, and Bioregio. So there's a lot of things that you can learn, and we hope that you get inspired through this policy brief and also through our workshop today. So without further ado, I would welcome again our two keynote speakers, and I would ask Jean-Benoît to start with his presentation and let us know what it takes to meet the Biowaste challenge from the view of ACR+. The word is yours.
Sorry. Well, thank you very much, Astrid, for your nice introduction. I'm trying to share my screen and unmute myself at the same time, and I messed up a bit. Well, I will try to summarize what we think we need to take to meet the Biowaste challenge in 10 minutes. It's a bit short, but I'll do my best. Quick word about ACR+. We are the Association of Cities and Regions for Sustainable Resource Management. It's a long name, but it's self-explanatory. We are a network of cities and regions working on circular economy, and we are trying to help our members to facilitate the exchange of good practices. We engage in many EU projects, some of them at the top of the screen on food waste and bio-waste prevention. And we are trying to see what the key challenges are for local players and how to overcome them in collaborative approaches. Well, to talk a bit about food waste collection in Europe, because I think that's the main issue when we talk about bio-waste. There's garden waste also, but it's less of an issue. When it comes to food waste, we are still lagging behind. We assess that there's between 15 and 20% of food waste that is separately collected in Europe, which is very low. And from what we know, we've got many different approaches and many different level of performances from one territory to another. So obviously there's some member states that are more advanced, that have been dealing with food waste and bio-waste for much more time than the others. And as with waste management, there's very different approaches that reflect different constraints, different history, different strategies. When it comes to collection modes, to separation systems, sometimes you will sort food waste from garden waste, sometimes you collect them together. Some even sort them out of residual waste. You've got centralized scheme with big units and different decentralized scheme with collective composting, home composting, so very different strategies that works more or less well across Europe. And when it comes to best practices, well, this general framework that we got out of our comparisons benchmarking project with local authorities, it applies to waste management in general, but especially for bio-waste and food waste management. As far as we know, people get the right sorting behaviors when you give them three things: the right information, a convenient way to sort their waste, and the motivation. And usually we tend to think that people not sorting their waste don't care about that or are not motivated, but in many cases, it's also because they don't know what to do, they didn't get the information, or they don't have a convenient way of doing it. And convenience is very important for food waste. When it comes to information, what we see with front runners and good system, they have a proactive communication, meaning that they just not only make the information available, but they make sure that people get it, even people living in flats or in places where it's more difficult to reach them. Communication should be frequent. It's not something you do at the beginning of a collection scheme and then forget about that, because people will just be less and less motivated if you're not reminding them about what they should do. We used to communicate on what to do, but people are also interested in knowing why they should do it, why they are changing the collection system, where the waste, the sorted waste is going, like the reason why we ask them to sort their wastes. And it's important also to link that with the people's concerns, because as far as we know, waste management, waste collection does not really appeal to people. It's not something very appealing for them, but if you can show that sorting your waste is good for climate change, for biodiversity loss, or for any other concern that people might have, then they might be more willing to do the right thing. And then when it comes to communication, it's also important to think the different target group. There's people that live in houses, that people living in flats. There are people that have issues with time, don't have time to sort, don't see the point. They don't have necessarily all the same concern, and also important to adapt communication to those different type of people so that you just don't only talk to the people that are aware of the environmental issues. Convenience is really important with food waste because it's not really the most pleasant fraction to sort. It can smell, it can bring flies, it can leak. So a good way to help people to sort is to provide them pre-collection equipments like bags or bins that they can fit in their kitchen, and also to adapt the collection system to their constraints. As far as we know, we get better results with door-to-door system, better quality, more quantity. It's important to have a collection frequency that also fits the size available for people, and maybe have different system across the city, different system for people living in flats with less space than for people living in houses with gardens, for instance. And then motivation, as I told you, it's not the only thing you should work on, but the clear difference between, let's say, front runners and the others is that front runners really use strong incentives. And for biowaste, if you want to reach high, and especially food waste, if you want to reach high capture rates, you need to use strong incentives. So the most common one are pay as you throw. There's also the possibility to make it mandatory and control the fact that people are sorting. But there's different options that I will give you some examples. Some good practices, so you might know them. Milan is a very, like the most famous case study of biowaste collection in the big city. And what they did to do that is an extensive communication, the distributed collection kit, and they also had this transparent bag for residual waste and frequent control of the sorted fraction to ensure good quality. And they could reach a very, very high collection rate and still keeping contamination very low. Another example in London, a borough, but it's not the only one that did that, is if you don't want to do a pay-as-you-throw or an obligation, you can just reduce the collection frequency for residual waste. Well, it's not that easy because people are happy to have more collection as much as possible, but making collection frequency for residual waste less frequent than food waste will promote the use of like food waste collection to get rid of the smelly part of waste. And actually, after they did that, they had an improvement of 50% of the collected quantities, and they could keep a low contamination. And another well-known example is what they did in Parma. In Parma, they shift from a bring bank to door-to-door collection, and they kind of adapted the collection system to the different typologies. So you've got a very dense urban center where collection is more frequent. You've got smaller bins, and you've got the suburb area where you've got houses and stuff, and the collection frequency is a bit less frequent, and you've got larger bin. And they also implemented a pay-as-you-throw where they give a certain amount of residual waste collection routes or residual waste bags according to the size of the household. And if you want to use more, then you have to pay. And in a few years' time, they could double the collected quantity, and now they reach 100 kilograms per capita per year of food waste, which is very, very high. Something very important on food waste is that collection of food waste is very important, but when you consider the link with food waste and climate change, it's also interesting to put stuff in perspective. So these are some results from a campaign we lead at ACR Plus called the More Circularity, Less Carbon campaign, where we help our members to assess the footprint of municipal waste, the carbon footprint. And for 6 of our members, we did the assessment. And this is the carbon footprint per capita of food waste treatment in several cities and regions. So you can see that for the most part, it's not that high. When you landfill, you've got a negative impact, like you generate carbon emission, but you can also avoid emission by proper recycling or even with incineration. Denmark, they've got a very effective incinerator plant, and they can save emission. But when you compare those emissions of the end of life of food waste with the emission emitted during the production of food and the consumption of food, well, you can see that the end of life has a very small impact. So in blue, you've got the impact linked with the production of food, so growing of food, cattle production, etc., the food processing. And you can see that the impact is much more significant than what you can get or save by doing the right thing with food waste management. It means that the main potential, if you want to address climate change with food waste policy, is really prevention. And on that, we really need to move forward because so far, we've got very little actual reduction across the member states. To finish, some policy recommendation that we made in Interreg policy brief that we proposed. The first one is that we need to work on the whole food value chain to reduce food waste and losses. So we need to attract the awareness of the different stakeholders on the issues, also with the environmental, but also the economic issues of food loss and waste, and try to align the different steps of the value chain to better align, for instance, consumption and production. We know that economic instruments have a huge potential. I told you about pay-as-you-throw and collection, but we also need to strengthen the economic instrument to prohibit, to reduce the landfilling of food waste and losses, and to promote separation. In many countries, food donation, there's still barriers, regulatory barriers that can be lifted, and also economic incentive to boost food donation. There's also need to help at the local level, the food banks and charity system, so that they can make the most of it. And we also know that promoting shorter food circuits have a benefit on food waste generation. And beside food waste and food losses, we should also consider these food waste problems within local food system, because there's lots of positive synergies with making food redistribution, valorization more local. Just a final important recommendation, like food waste collection should not be taken as an insulated system. It should address the entire value chain. So taking into consideration avoidable food waste that you don't want to collect and treat, and also taking into consideration who will use the final end product, who will use the compost, the digestate. So it's really important to fit that all together. We need to add more on food prevention, and we need more data, more ambitious strategies, because this is a real issue for climate change. I think we already have several good examples of good practices focusing on quantity, and we need to investigate more about the quality of sorted waste. There's some issues with microplastics in compost that we probably need to better improve. And there's also several promising valorization routes. So there's project doing biopesticide or insect rearing out of food waste. And we need to further develop those kind of bioeconomy approaches, but more importantly, we need to make sure that those approaches are also circular, because we just don't want to transport the linear economy into the linear bioeconomy. So that was it. I hope it was clear enough and short enough, and looking forward to discuss that with you today. And again, many thanks for the invitation.
Well, thank you very much, Jean-Benoît. It was very clear, and it was also very timely, so don't worry. I think it would be, it's very interesting what you're saying in terms of that we have to address the entire value chain, that we have to put much more focus also on the prevention of food waste, and then also look into the quality, because there should be qualitative material coming out of the recycling of food waste, for example. We have a question to this end. Aura Liski is asking what you mean by contamination. I think you mentioned that in the Milan example where you said 5%. So what is it that contaminates the separately collected biowaste?
Well, this is the impurities, like all the non-food waste materials that you find in the food waste bin. So it can be plastics, can be packaging, like every waste that is not meant to be composted or digested afterwards. So that all the what you don't want to have in your food waste.
Yes, and I think that is one of the challenges that to ensure that the quality is very good, have regular controls, for example. I think that's also one of the recommendations that you've made. So it's very important to see how this can be ensured as in terms of quality. We also had a question with regard to more examples, more real life examples. Is there any publication that you have where you can point us to? Jean-Benoît, for example? I think ACR Plus always has lots of interesting documents.
We did several reports on food waste. Let me think about them. Within the Decisive project, we did like it's 3 years old now, but you can still find some interesting. It's the state of the art of communication and incentives method that we did. And it focused on food waste collection and food waste prevention. And we tried to give good practices. And also we scanned the literature to see what works for commercial activities outdoors. So definitely I will post a link in the chat for you to check.
Thank you, that's great. And I was hoping you would say something like that. And we have also a question from Marie Guiton, which is asking how it is possible that incineration leads to negative carbon emissions. Can you just very brief answer on this?
Yes, well, the model we use only take into consideration non-biogenic emissions. So the biomass emission, the emission linked with the burning of biomass are not accounted. And then when you burn food and you recover energy, you substitute this energy to the energy produced by the traditional ways. So in the case of Odense, it's natural gas, and the energy that they produce, it's heat. They produce heat, and the heat they produce with the incineration of food waste is substituted to heat produced by natural gas, so you avoid this emission. So yeah, it leads to negative emission as long as the energy is carbon intensive, but as soon as you have a carbon neutral energy, then it doesn't lead to any saving actually.
Well, thank you very much. I'm sure the methodology for calculating that is written down somewhere as well, if there is more specific interests. Okay, well, thank you very much, Jean-Benoît. I would now like to give the word to the European Biogas Association and give it to Mieke Decorte to be more specific and ask also what it takes to meet the biowaste challenge and how biogas can be a key enabler for that. Mieke, the word is yours.
Yes, thank you. I think now my presentation is on full screen mode.
It is.
Okay, perfect. So thank you for the introduction. I'm Mieke Decorte from the European Biogas Association. So I will focus in my presentation more specifically on biogas production from biowaste and how this contributes to the biowaste challenge. And in my first slide, I have a short, summary and a recap about biogas production. So of course, in Europe, to produce biogas, different feedstocks and different streams are used at the moment, of which biowaste is a very important one. So you have biowaste from the households, but then you also have food waste that comes from the industry as well. And which also goes to biogas production or which also can go to biogas production. Then if you produce biogas, you have the digestates, which can again be used for agriculture and to grow new foods and to replace mineral fertilizers. And then with this biogas that you have produced, you can do different things. You can produce electricity and heat using a CHP. This is done a lot in Europe, but more and more biogas is upgraded to biomethane and injected into the natural gas grid, or the biomethane can also be used in the transport sector. This is just a bit the overview. And then if we look specifically into bio-waste as a feedstock, well, as EBA, we really expect that there will be a growth in the potential to produce biogas from bio-waste. And the main reason is, as already mentioned in this workshop, the better sorting and the better waste management that we will have and that we anticipate in the coming years. This will be very important, and this will just increase, let's say, the supply of food waste to produce biogas from. Um, uh, what Well, currently biogas is also produced from landfills, but we need to take into account that this will decrease because we want to avoid that this organic waste goes to the landfills, and we want to separate it at the source separately, and that it can go directly to a biogas plant. Um, so we see also that biogas production is a real opportunity for composting facilities, because as a composting facility, you can invest in anaerobic digestion as a pre-treatment of the biowaste, and then you can maintain your composting facilities, and you can maintain the compost as an output. But in addition to the compost, you will have renewable energy production at your at your plant, and we see that this is being done in new facilities, but also in existing facilities that already exist for 20 or 30 years, that they investigate this option to invest in AD as a pre-treatment for the bio-waste. And then this is mainly done for bio-waste from households, not from the industry specifically. What is also another trend that we see is that relatively more biomethane plants use bio-waste compared to biogas plants which do not have an upgrading. And one reason this can be due to is that for food waste, um, that generally another technology is used, which is dry anaerobic digestion. And because the feedstock is more dry, you will also need less drying of your digestate afterwards. So you will not need the heat of your CHP. And for this reason, biomethane production can be very interesting. Then if we move forward towards how much plants are being built in Europe, on different type of feedstocks, and this also as well on bio-waste, we see that actually, while this graph shows the newly installed biomethane plants in Europe each year, and you can see in the blue, the blue part is biomethane from bio-waste, and you can see actually that throughout the year there's a constant new flow of new plants being built on bio-waste. Which is of course interesting to know. And I have also looked into details which are the countries which are now leading in biomethane production from bio-waste. And it's actually very clear that, for example, in Italy, this is done a lot. You can see again the blue part of this figure, and in the last 3 years, a lot of plants are built using bio-waste. In the total of 30 new biomethane plants, the majority actually runs on bio-waste. And this is also encouraged via the Italian biomethane degree, which is still ongoing for I think for 2 more years, and after that they expect a new biomethane degree. So we actually expect in Italy that many new plants will be built as well in the coming years. Then for Belgium, we see something similar, and there we see actually that existing composting facilities, they really have this interest to invest in a digester as a pretreatment step in the composting process. The first biomethane plant in Belgium actually has done this, and a lot of experience is gained from this, and now additional composting facilities are investigating this opportunity and also have plans to invest in this pretreatment step. Then as a third country in Finland, and I saw that we will have another presentation from Finland later on in the workshop, but also in Finland, biomethane production from biowaste is very popular. And actually in Finland, you can see that also biogas plants not upgrading, a lot of them also use biowaste as a feedstock. It's actually one out of 3 of the biogas plants, they are using biowaste as a feedstock. If we then look more into the general numbers of biomethane production in Europe, you can see that this has grown a lot in the last decade, and that in the year 2020 we saw a very steep increase, and this growth was double than the growth in 2019, and we expect for 2021 an even higher increase in the biomethane production. So this is really a sector that is growing a lot, and that we expect a lot from in the years ahead. In terms of how that we need to put this production of biogas and biomethane into relation in the total gas consumption of Europe, we see that we currently produce around 4.6% of the European gas demand. In 2030, this can be around 11% of the European gas demand that can be covered with biogas and biomethane. And then if we take into account that gas demand will decrease as well in the future, biomethane can cover 30 to 40% in 2050. So this is just to show that biogas and biomethane production are also really relevant on the larger scale, and that they can really contribute towards decarbonization. Then another point that I thought was interesting to highlight for municipalities is that there's a real opportunity to produce biomethane from the biowaste from the municipality, and then to use this biomethane as a transport fuel, and that can be used for public transport, or that can be used in the trucks to collect the biowaste. And this is really a very nice circular approach, that the biowaste collected with those trucks, that those trucks can run again on the energy actually produced from this biowaste. So then we speak of biomethane in the form of bio-CNG and bio-LNG, which is compressed and liquefied biomethane. And if we look into the total volumes that are anticipated already for the coming years, based on the plans that are currently in the pipeline and plans that are being built right now, we expect that by 2024, at least 25,000 energy trucks could be fueled with biomethane. So this is also, of course, very relevant scale. If we then look into the amount of jobs that can be created with biogas and biomethane production, this is on the European level, it's 420,000 jobs by 2030, and even over 1 million jobs by 2050. So this is, of course, also very good to know that if you produce biogas from local streams, then you will also create local jobs, which is, of course, also very good for the local economy. And that this was my presentation. Thank you.
Well, thank you very much, Mieke, and also making the extra effort to focus on the biowaste as a substrate for the biogas production. I think that is very much appreciated. Since we are talking here about recycling of biowaste, I would like to make the point again that biogas production or anaerobic digestion is only counting as recycling if it produces also a fertilizer or a compost afterwards. So we have been writing what we call a help desk on this with much more information so that you can also read this. So please always use this in combination. I think it's very interesting to hear about the biomethane transport opportunities. We can maybe in the future talk a little bit more about that. There's several big cities also that are using it, such as Paris, that are using all their bio waste collected for biomethane production, and then they run all their waste collection vehicles on it. I think it's an excellent approach. Mieke, do you think the fact that Italy is using biowaste as a substrate for a feedstock for its biogas plants comes also with the fact that they're quite good already at the separate collection of biowaste? Do you think there is a link there?
I don't know the figures about the separate waste collection in the different countries, so I cannot really give more details on that. The main motivation in Italy to build biomethane plants is because they want to green their transport sector, and actually all the biomethane is also used for the use and the transport. But I would think so, yes, if they can build so many plants on biowaste and if they have still so many in the pipeline, I would hope that they are very good in waste collection.
I think so as well. I think that it's a first step to it. The quality of the feedstock is of course very important. Do we have a specific approaches here, because it is really not the best thing to put plastic or packaging or microplastics into a biogas plant? Are there any
yes, exactly,
ways to avoid that?
Well, indeed, if you have a lot of contaminations and impurity in the biowaste collection, well, which is of course a challenge because it are households which are separating this. Especially for the if you have wet digestion, especially for the pumps and for clogging, this is very difficult, and that's also a reason why we see that for biowaste it is mainly dry digestion which is used, which has less pumps and less things that need to transport the waste, and this is one way to tackle this challenge. This type of technology can handle better the impurities and will not get immediately stuck if there are forks or spoons in the waste, for example. This technology can handle this.
Thank you, Mieke. While you were speaking, and already a little bit before, there were quite a lot of discussions going on about hydrogen. So maybe you can also say some words about that, because hydrogen is a hype. Biogas is a decentralized possibility of producing energy. How do you compare this? Where do you see the opportunities for linking this? Could you also say something about hydrogen and biogas,
Yes,
please?
I think making synergies and thinking about how these both types of gases, biomethane and hydrogen, will work together is very important. And we see different ways to do this. On the one hand, well, as I presented in the beginning, biomethane would cover 30 to 40% of the gas demand, or is capable to do that, which means that other types of gases are in any case needed to come to complete decarbonization, and hydrogen will of course be an important one there. Another point that we see is that you can actually also produce hydrogen from biomethane, which will then be biohydrogen. And this can be investigated in which cases this can be interesting to do so. And on the other hand, you can also increase the biomethane production with hydrogen. So with directly combining hydrogen into the biogas reactor, you can increase your biomethane output. So it actually works both ways, and I think it really depends on the situation and on the business case and on the area, which combination and which route needs to be used. I think they will exist next to each other.
Thank you. Yes, we have Michaela Frinku saying hydrogen is seen as an option for storing renewable electricity that is not consumed and would be wasted. I think something similar could be said about biogas as well.
Yes, of course. Well, in general, it's having energy in the form of gas is a cheap way to store energy. If it's hydrogen or if it's biomethane, it's the same reasoning. It's much cheaper than when you store electricity into a battery. That's much more expensive. So I think both hydrogen and biomethane are solutions to store electricity. And well, and in addition, if you produce biogas, then you can choose at that moment if you want to produce electricity from it or if you want to produce biomethane from it, depending on the hour of the day and the demand for electricity and so on.
Thank you, Mieke. We also have a question from Adam Szymanski, who asked or says the use of biogas still raises questions about final emissions, while hydrogen is a versatile and surplus reducing carrier. Would you agree to this, or do these? Yeah, well, I think you said it already. They're complementing each other, but please also say something about that.
Well, we need to understand, as was already well mentioned as well in the first presentation, that when you produce biogas from biowaste, that this biowaste has already taken carbon dioxide from the atmosphere. So when the biowaste has been growing, so this means that the carbon dioxide is actually recycling in circles, because if you will use the biomethane, you will have biogenic carbon dioxide emissions, and they are actually recycled from the atmosphere. So they do not add extra carbon dioxide to the atmosphere. And in addition, it's important to use the digestate, and this digestate can or compost, and this compost or digestate can bring more carbon to the soil, and in this way create negative emissions.
I also have a small question from my side. You mentioned landfill gas, or often also called biogas. You know, in my view, landfill gas is not so potent anymore, right? I mean, the best thing is to use the gas right away in a biogas plant. Do you have any comparison? What is the gas yield which you can get from landfill gas and versus a normal biogas plant?
Well, it's very clear that well, there are still existing landfill plants. While that the landfills, they exist and they will recover the biogas, but there are not many new ones. And of course, this is good news, because this means that the organic waste does not go anymore to the landfills. And of course, it's much more efficient if you directly use this biowaste to produce biogas from, than if you first go to a landfill and then the biogas will be released in a very, very long period of time, compared to if you stimulate this process of digestion, and if you can collect this biogas much more quickly. So I think that's certainly better.
Thank you very much. Maybe I can also ask Jean-Benoît, do you see your members using the combination of biogas and composting or fertilizer production more and more, or how is your feeling there?
Yes,
yes, we see very different approaches, I must say. I think the main focus right now is to implement collection, actually. And then it really depends on other choices. I don't think there's a specific focus on the strategy. Sometimes they want to link that with the production of renewable energy. So it depends on other existing strategy that might push them for most biogas. There's also some, like, it depends also on the responsibility. You mentioned Paris, but there are other cities that want to close the loop also with energy. But to do so, you need a certain mass. sufficient quantities, so it's not for any territory, I would say.
Yeah, critical mass is important. Quality is important. Thank you very much. I think we're going to see this more and more. We have a question from Ahmed Abu Ismail. I'm very sorry if I pronounced that wrongly. You're saying that CO2 content levels are much higher for biogas. So what upgrading technology are you using? Please mute yourself. What biogas upgrading technology can you use, for example, for the biomethane, Mieke?
There are, yes, of course, if you produce biogas, it will consist of approximately 60% methane, so from the gas molecule, and then another 40% carbon dioxide. So you need to purify and upgrade this. And there are several different technologies which exist in parallel in Europe. The last year's membrane separation is the most prominent one. At least in number of plants being built. But you also have scrubbing, water scrubbing, amine scrubbing, pressure swing adsorption, and some others that still exist next to each other. But at the moment, membrane separation is the most popular one.
Thank you very much. So if you have more questions, please let us know. We still have some minutes. What do you see as opportunities for using biowaste streams in chemistry for lubricants and coatings and in building as insulation? This may be a question also to Jean-Benoît. I don't know if you know anything, what we can say about that.
Not specifically. We know that there's many different innovation projects focusing on making, like valorizing biowaste into new products. And so I don't have any clear idea on what it is. We just want to make sure that we do that in a circular way. Like what we see is also a tendency to move from fossil-based solution to bio-based solution, but without changing the model, without making it circular. So we see that kind of innovation as a positive solution, but it does not, like, we have also to think really how to make them circular, how to change the system in general.
Thank you. And I would say, René, we will look for some good examples for you. There are several projects and interesting examples to this end. So we will come back to you in writing after this event. So then Piotr Baczak is saying that we should not only think about the end of pipe solutions. So we have the waste already. We should, of course, also focus on prevention, a point that was made also very strongly by Jean-Benoît. So absolutely right. This has to go hand in hand, and prevention is absolutely necessary. We are losing so much food. I think food waste is the 7th biggest CO2 emitter if it were a country. So so prevention is absolutely necessary. Well, we have third biggest emitter. Thank you for correcting me. So yes, I think we have had already a lot of interesting questions, very good discussion, and now we can go into much more detail. We have great examples from different partners from Interreg Europe projects, which have been working in the area of using biogas and producing compost, also in home composting and composting schemes. And this gives us the opportunity to break out in our breakout sessions. We take Mieke and Jean-Benoît with us as well, so we don't lose your expertise. So you have been indicating beforehand in which session you would like to be. And you will now be allocated automatically to that session. I guess you can also change if you really don't like it, but we will come back together afterwards into a plenary session where we will hear the reports, what has happened, and then also hear about the future of Interreg Europe and the policy learning platform. And again, you have a possibility to vote on future subjects. Yeah, so with this, I would ask you now all to proceed to your rooms, and I see you in the breakout session. So biogas is session 1 with Katharina, and composting is session 2 with Astrid. Hello. Okay, see you back.